Hello guys, in this video I'm going to show you how to solve sum of part numbers. So given a binary tree where each node can only have a digit value from 1 to 0 to 9, each root to lead path will represent a number. Find the total sum of all the numbers represented by all paths, right? So for example, given this binary tree, we want to find the total sum of all the numbers represented all parts. As you can see, this binary tree is in this binary tree there are a total of 3 parts, right? The first one is 1 2, second one is 1 3 4, and last one 1 3 5. Each part will represent a number, right? So we have 3 numbers in total, 12, 134 and 135, right? We want to find the total sum, right? So I will add all the numbers together. So the final result will be let's say 2 plus 9 is 1, right? Remember 1 plus 6 is 7. Remember 1 is 8, right? And 1 plus 1 is 2, right? So the final result is 281, right? So it is not a difficult one, right? So what we need here is just to keep track of the current path, right? As we wanna go in depth, right? Because we want to find the number, right, that represent a path. So it means we have to go from the root to the leaf node, right? So it means when I use depth first traversal, right? So the idea here is we need to keep track of the current path. So it means at each node wanna add to our current path, right? As we go down the tree, and when it reaches the leaf node, I will have the current path is the number is a number, right? So wanna add that number to a final sum, right? So after visiting all the parts, we will have we will have final sums. So so we need to so here is our functions, right? Each node were given this class with value left and right point. Okay. These functions will receive it takes in an argument which is the root node, right? So because when I use recursions here, so it means as I described earlier, when I use we need to keep track of two pieces of state, which is the current part, right? Um, the current path and also the final sum, right? The final result. The current part here could be could be a could be an array, right? Like at the root node, when add one to the, for example, initially it's a current part. Initially it's a empty array, and like at one, when I add one here, okay, wanna go in depth and wanna go to the left first. So come to two, add two to the current part, right? And two is a leaf node. So okay, we finish with this path. So we can use this uh, path array to form a number. Uh, that is one way, right? But another way is to build up our number, right? Our number uh, as we traverse tree in depth. For example, initially it's zero, right? And if we go to one, I'm gonna take the current number times 10 and plus the node that we are currently visiting, which is 1 plus 1. So it is 1. It will produce 1 here, right? Okay. The next number is okay. The next number is 2, right? So our expected number is 12, right? So uh, here we can take 1 in the previous step, right? Times 10 plus, plus 2, so it will produce 12, right? So the idea here is we take the current number times 10 and plus the value at the current node, at the node that we are visiting, right? So current part will, it is a number, right? So initially it's 0 and final here is 0 also. Okay, so the idea here is um, one function call will be um, one function call is just a uh, one function call passing root means we are visiting the node. We are visiting one node, right, in our tree. So yeah, so let's say we are visiting this node, right? So we're gonna build up the current part number. So the current part here will be current part 10 times 10 and plus the value of the node that we are visiting, which is root.val. Okay, Mm, okay, um, so after visiting the current node, right, there are couple of possibilities, which are, is it a leaf node, right? What if it is a leaf node? So it is a leaf node when we don't have a root left and we don't have a root right also. So here's leaf node. It's a leaf node, right? So what we want to do here is that um, we want to add the current path to the final, right? Current path plus final, whoops, final um, will be the final, the current value final plus current path. Right? Okay, so um, the other possibility is it is not a leaf node. Uh, if it is a leaf node, we add the current number to the final result, and we want to return right away, right? We don't want to traverse, um, continue the traverse from here. But if it is not a leaf node, if if it comes here, it means we do have a we do have either leaf node, we do have either left or right, or both left or right, or both left and right, right? So left child of, we have two choices here, left and right, right? Root left, root right, and it is not guaranteed that left, both left and right are not null, so we need to check here. If the child can be left and right here, it is not null, then I want to continue to traverse in that directions, right? So sum path number, uh, I'm gonna pass in the child node here, current path, and the final, mm, and after all, like after come back from the, when I go traversing that, right? 1 to 2, like for example, 1 we have two choices, 2 and 3. We go 2 is the left node, the leaf node. When I add the current part, which is 12, to the final here, right? So 2 is the leaf node. We don't have choice. We don't have choice to go further down, so we come back to 1. So it means we probably want to backtrack here. For example, here the current number is 12. And if we come back here, we want the current number is 1, right? So we can reverse this these calculations, the current part. Um, so for example here, after visiting 2, we want to take 12 minus 2 is 10. 10 divided by 10 is 1. So we have 1 here. But it is we probably want to do something uh, we can do something better than that. Uh, Here we probably don't want to modify the current part, right? We want to scope this current part to the current recursive functions only, right? So when it comes back from the below recursive call, the value is the same, right? So the current part is scoped to these recursive functions only. So I want to let's say new current path equal to current path times 10 plus root math. Okay, so here I want to add up the new current path instead, and here I want to pass down the new current path. Okay, what else I want to do is, okay, so at the end here, so okay, so by doing this little trick, we don't have to kind of backtrack. We don't have to backtrack after the recursive call, right? If we modify current path directly, like after visiting this child, and here we need to backtrack to reverse these calculations, right? So at the end I'm going to return final, but there's one bug in our implementations here. Pause the video and try to find the issues. Okay, I'm gonna add a comment here. We visiting current node. Okay, the issues here is the final here that we pass, and we are passing a primitive value between the uh, between recursive calls, right? So it means we are, as we pass it to a recursive function, as we pass it recursively, the final will be a copy, right? A, let's say another value, a copy of the final in the uh, body of the caller, right? So at the end, the final will still be zero. So one one way to fix these issues is to I want to pass the object instead, right? So I can do something like final is the object that inside has a values that is initially zero. Um, so here I want to modify the value of the final object instead. Okay, so here we are modifying the object final, right? Which is the same for every recursive call, right? So down here, final, I will return final dot value instead. Okay, I think that is it. Visit, we build up the new current path. Okay, if it leave node, and add it to the final value. Okay, then it comes here. It means it's not a leaf node. I have two choices, left or right. Check if it not no, I will go that way, passing in the new node that want to visit, right? The new current path, and the final is objects. Okay, I think that is it. Just eight and three. Okay, it works. Perfect. Just to double check, I'll return one here, and I expect my test will fail. Okay, so that is it for this video. Sum of part numbers using depth traversal. So thanks for watching. See you in the next video.